see and hear you loud and clear.
Okay, great. Well, thanks, Oleg and Stephanie and Saga for inviting me again to present this talk. There's nothing. It's always nice to be invited, and it's always nice to be invited again once you give a talk and you put all the work into it. It's nice to be able to recycle it. So the talk today is on it's called Rediscovering Semblana, and as we're going to find out, Semblana is one of the deposits at the Neves Corvo VMS mine in Portugal. I guess I should also thank my co-authors. They were Victor Araujo, who is the geology manager at Neves Corvo, and Scott Napier, who's principal geoscientist at Mira Geoscience. And important to know is that this talk would probably have been better if it had been given by one of those two, because Vitor is still at Neves and Scott was at Neves when Semblana was discovered. So these two, my two co-authors, they both had boots on the ground. So just a few more acknowledgements. The other people who have helped out, Mira, of course, Saga for inviting me, Lundin Mining, High Size, and Bell, they both contributed lots of data and lots of help to the presentation. And Dick West, he probably wrote a seminal paper that was presented in Exploration 17 on on Semblana and what we knew at the time. This is really just kind of not rehashing his work, but expanding upon it. I do like this prologue here, which was written shortly after the discovery, that Neves was discovered as the result of a synthesis of the data from several different prospecting methods. Without geophysics, Neves Corvo would not have been discovered. On the other hand, there would be no mine in Neves Corvo if the exploration had relied solely on geophysics. So what this really speaks to, I think, is integrated nature of geoscience. That no one technique these days is really a smoking gun, and we need to work in concert with the others to extract the full value of what we're trying to achieve. So an outline, just a brief introduction, geological setting, the original discovery of Neves in 1977, Semblana, and then rediscovering Semblana. So basically, I want to talk about, it's now almost 20 years after the fact that Semblana has been discovered. If we had today's data and today's technology, how would things or may have changed? And then we can have a wrap up with a bit of a discussion. So first a bit on Lundin Mining, and this is interesting. 2 weeks ago, things changed. Or last week, sorry, things changed. Lundin has a underground operation in the United States called Eagle. It's a VMS, nickel copper. We have copper in South America and in Brazil, in Chile, and something in Argentina. And then Neves and Zinkgruvan, as it turns out, they were sold last Thursday. So they were now in the realm of Ludin. I was kind of sad to see them go, especially Neves, because it was a wonderful place to work and visit. But such is life. And then I put 10K up there as well, just to show that Lundin has in the past, and not really Lundin Mining, but the Lundin Group has had a presence in Africa, because we were part owners of 10K between 2007 and 16. So the Neves Corvo mine, it's a VMS deposit. It's located in the globally important IPB, that's the Iberian Pyrite Belt, which is in southern Portugal and Spain. Neves is in Portugal. It was discovered in 1977 by drilling a gravity anomaly, a misinterpreted gravity anomaly, as it turns out. Lundin acquired it from Eurozinc in 2007. Before that, it had been it was a 50-50 JV between Semincor and Rio Tinto. And there are currently 7 different bodies with published reserves and/or resources. It's predominantly a copper mine, and the grade is, 2 point something percent. So not super high grade, but given its size, it's a pretty impressive deposit. Semblana, which you can see there kind of on the right, was discovered in 2010, and it was a true integrated discovery because it had pieces of geological modeling, constrained gravity inversion, surface TEM, and borehole EM. These all participated in the discovery, and it has an inferred resource from 2023 of about 7,800 kilotons, grading almost 3% copper. So it's fairly high grade compared to the rest of the deposits. 25 grams per ton silver. Um, but if it's currently not being mined, and there are several reasons for that. But one of them is that it's at 800 meters depth, and as you can see, it's a little removed from the other deposits. So a bit about VMS deposits, if people aren't really familiar with them. It's a metal sulfide ore. They're mainly copper and zinc. They're formed at depth on the seafloor by the precipitation of hydrothermal fluids. The modern analog is the black smoker, which was first discovered in 1973, I think it was, off the Galapagos. Um, just an interesting segue. I spent part of my career working I was seconded from Tech to Nautilus Resources, and we were looking for black smokers. Well, we were looking for SMS deposits, seafloor massive sulfide on the seafloor. So um, we now know that these things like Neves, Brunswick, in Kidd Creek, all these big VMS deposits were formed on the seafloor. So they're dominated by volcanic activity, coincident with volcanism, significant sources of the world's copper, zinc, lead ores, and they also have decent Cohen byproducts. The Iberian Pyrite Belt, I mentioned that before. It's 250 kilometers by 50. It's this belt covering southern Portugal and southwestern Spain. It hosts over 2 billion tons of massive sulfide mineralization. It's been mined for over 5,000 years. I think it started with the Phoenicians and went through the Romans. And then there was a huge hiatus, basically in the 2000s. There wasn't, or since in the last 2,000 years, there was very little until about the last 100, when 1850s or so, when it started up again in and around Rio Tinto. So there are over 90 deposits, and 8 of them are classified as giant, and one of those includes Neves Corvo. The stratigraphy there, I'm going to show you a cross section as well. It's incredibly complicated, but it can be distilled down into an upper flysch, and then there's this VS unit. There's an upper and a lower, often called the VSC for the volcano sedimentary complex. There's a big thrust that separates the two, and then the basement is these phyllites and quartzites called the PQ. And the massive sulfide is generally located at the top of the lower VS, and then with the upper having been thrusted above the lower. So I mentioned complicated stratigraphy. Here's just a section just to show you it is quite complicated, and you can see where the massive sulfide is sitting on top of the lower VS. In terms of physical properties, as expected for a VMS deposit, we'd expect to have some dense rocks. So there is a decent contrast. The resistivities are difficult. Let's say that the massive sulfides can be less than 100, but a lot of the other rocks are not that much more conductive. There's lots of pyrite, lots of shales that give, if not spurious anomalies, are just shielding the conductors at depth. And there are some massive sulfides, but magnetics is not really a method to detect these things at Neves Corvo. just the regional geology map, we can see two kinds of flysch. So basically, Neves is this little anticline. Well, it's at the end of this anticline. It's actually mostly covered, but it's sitting out. Ajustel is another one of the super giant VMS mines in the same area. It's about 40 kilometers away. I told you about the regional mag. So the VMSs, they do show up. As I said, Neves is undercover, and by the time you get to Neves, it doesn't really have much of a response. The São Domingo, it is a little outcropping wedge of this volcanic sedimentary package, so it does show up. The regional Bugey, if we look at it at this scale, it's not really showing a lot. But if we zoom in, or start to do some filtering on that, we can start to see that there is a local high, and an expression of these rocks. I have to keep moving me around because it's obliterating parts of the presentation that I want to show. So the Neves discovery, basically in 1969, there was a big gravity survey over most of the area, and there was a target that was found at Neves. And as is often the case, our mineral deposits are occurring on the edges of surveys or the edges of map sheets. So there's a little high that was interpreted. In 1973, hole N1 was drilled, but it was stopped in the Kulm, which is the kind of the Flysch these days, below the VSC, because there was thrusting going on that they didn't fully understand. The anomaly was not explained. They wanted to drill a second hole. I think at that time there was a coup, change of government in in Portugal. Everything stopped, and they modeled Neves as too shallow, not understanding the again, the thrusting, the complex nature of the thrusting, and they missed it by about 100 meters. So in 1974, it was argued to go and collect some more gravity stations. So they surveyed the other side of the sheet, and you can see that they kind of closed the Neves anomaly. And then on this here on the left, we've indicated where Corvo and Gassa and Zambojal exist. And this is part of the original, in the center, part of the original model. That geological section at the top is not nearly complicated enough. But they had noticed that there was this accounted for mass. So in 1974, they did these stations. They respected that there was this excess mass. They kind of doubted the original model, did some reinterpretation. And then in 1977, they finally got to drill hole N2, and they intersected 53 meters of massive sulfide. That would have mostly been pyrite, but at 350 meters, and that opened up the whole district. This is one of the first blind VMS discoveries in the Iberian pyrite belt. And then, as you can see from that gravity map on the left, Corvo, Grassa, and Zambojal, they would all follow within 2 years. Just a bit more about the physical properties, at least in terms of densities. All of the country rocks are basically sit in a quite narrow band, as does the basement. There are some stockworks that have sulfides in them. You would expect them to be a bit higher. And the massive sulfides are of course higher, but because of the depth, these things are hard to, it's really hard to see these as super discrete anomalies. So now as we kind of move into the Semblana part of the talk, Semincor, of course, had gravity over the whole area. They went and did lots of infill, and they contracted Mira in 2007 to do a constrained inversion. So Mira tried to level all the gravity. There were physical properties in hand. So they did their constrained modeling. They used VPMG, and they kind of iterate between a homogeneous and heterogeneous inversion, and they ended up with a 0.25 uh, gram per centimeter cubed isoshell. Um, uh, I don't know. Okay, like I said, this. Okay, maybe that's better. So here's Semblana in the right. They had these isoshells. Sorry, I went the wrong way. Um, they also did moving loop TEM surveys. As you see, Semblana wasn't really discovered, but they did these 1 by 1 kilometer center loops, and they put 2 or 3 lines through each of them. So Semblana wasn't really covered super well, and it certainly didn't have for a subhorizontal body. It certainly didn't have one loop, like a collar loop, right on top of it that would have coupled the best with it. They did a 1D gravity, or sorry, a 1D TEM inversion, and lo and behold, you can see these conductors in red, and this was all exciting. And you can see this down dip density isoshell, and that was kind of exciting. Um, so they were able to argue um, to plunk a hole in this. Um, there was lots of debate about the gravity. The problem with collecting gravity over 30 plus years in ground surveys is that mistakes happen. They get very hard to sort out after the fact. Field notes are lost and things were transcribed, right? There are transcription errors. So there's a big debate on that. But hey, we had this coincident anomaly with this 1D TEM, which I think in hindsight we're going to show was probably spurious. Anyway, they planned a three drill hole campaign. Just to review borehole geophysics, especially in the 3 component nature, there's the axial component that is up the hole. The U is in a vertical plane, pointing up at 90 degrees, and then the V would be 90 degrees to both of those. So the first hole they drilled was PSM 44. It showed a weak late time anomaly, especially in the A, a little off hole. And we can see in the lower left where these holes were with respect to Semblana. So first one was drilled to the west. And of course, the hole is actually kind of coming out of the page. So when we interpret the U component, it's telling us that we need to go to the left, which in this case is to the east. And that was a bit behind the hole. So then they drilled this hole on the east side. So they skipped all the way across it. And now again, the hole is coming out of the page a bit. So it's to the right. It's still behind the hole. And then finally, they drilled this SO8, which just nicked the side of it. It's still mostly an off-hole anomaly, but there was this one little bleb of in-hole, which of course they saw a little bit of sulfides in the hole. So this is the discovery hole. And there's the discovery. They had a box full of massive pyrite with chalcopyrite. So if we had to rediscover Semblana, how would we do that today? I think no one in their right mind should be advocating collecting ground gravity over 30 years and stitching them all together. You could do an airborne survey, in this case gravity gradiometry, and collect this whole thing in a week or two if the weather is nice. So this was flown after the fact in like 2012 or 13. This is what it looks like. And there I've got the claim block around Nevis. So internally consistent, multi-component, collected much more quickly. This compared to the ground gravity, which was collected over decades. And then, recently, this wasn't available at the time, but Bell Geoscience, they've advanced their processing game, so they can take depth slices. They now make kind of structural or frameworks, at least lineament frameworks of what's going on. and you can lay them across. And as it turns out, a lot of this does speak to the to the geology and the thrusting that we now know exists. So um, this really helps, or would really help with targeting these days. And then seismic reflection. Semblana was not a seismic discovery, although it well could have been, because before it was discovered and that drill hole was actually made in 2010, there was Lundin had wanted to collect 3D seismics, and Lundin is probably one of the mining companies who very early on um, appreciated 3D seismics and what it could deliver. Unfortunately, when it was planned, the global financial crisis of 2009 hit, and because of reduced budgets, it was canned. So 3D seismics never had the opportunity to discover Semblana, but this just shows, as we expect, that the stockworks and the massive sulfides should show up as impedance anomalies, acoustic impedance anomalies. We knew that seismics was likely going to work because way back in 1991, CGG at the time collected a whole bunch of 2D profiles, and one of them went over what is now the Lombador deposit, and you can see there how well it showed up in 1991. So maybe one of the questions is, what took them so long? Why did they have to wait until even 2007 before they finally decided to even consider collecting more seismics? But seismics is expensive, and in the mineral realm, we mineral geophysicists aren't really comfortable with seismics, if I can make a generalization. So I think that and budgets, that all kind of conspired. But here we fast forward to what the 3D survey looked like, and you can see some drill holes with mineralized intercepts, and Semblana really sticks out in the 3D seismic survey. So just a bit more about where everything is showing up in the two slices through the cube. So the seismics is really showing the top of the VSC, but it does penetrate below that. So you can see how Lombador showed up quite strongly. There's Semblana. There's another deposit called it wasn't Casa. I'll think of it in a second. That was a discovery of seismics. This one, Monte Branco, the one way down in the south, kind of under the tailings pond, that was a 3D seismic discovery. So on the 3D EM response, we already talked about the 1D. The 3D, and this is modeling that was done by Scott Napier, the 3D does not show Semblana at all. And if I just come back here, you can see that all these loops were in quite close proximity to the to the southwest of Semblana is Zumbergel. That's quite shallow. It's within the field of the transmitter from all of those transmitters. And Scott now thinks that the 1D anomaly that was processed under Semblana was really just the interaction of these transmitters with Zumbergel. So this basically, I guess, highlights, one of the caveats of using 1D inversions for things. You have to be very, very careful. Anyway, so on to this modeling. Scott, he did a 3D model, and he did a forward model, basically forcing Semblana in the forward model, and you really can't detect it within the noise of the survey. He'd have to make it about 10 times more conductive, and then it would show up as a measurable anomaly. We've never done any MT at Nevis Corval. I was arguing for it, and maybe we were getting close, but I won't be part of that since Lundin no longer owns it. But Semblana would be a good MT anomaly. I guess the caveat and what's unknown, of course, is we're in a mine environment. We're in an area with lots of cultural noise. People have lived in that part of Portugal for thousands of years. So could we see through the noise? We don't really know, but we would detect it if we could. And then, so almost wrapping up here, how would we rediscover Semblana? again, and this is what happened at the start. It was just plain old good geoscience. So we had high quality geophysical mapping targeting physical properties. We'd use airborne gravity gradiometry, magnetotellurics, or at the least low frequency B field TEM, 3D seismics. We'd do 3D constrained inversions. We'd integrate it all, and then we'd follow it up with 3D borehole EM. An epilogue, John Maynard Keynes, I'd rather be vaguely right than precisely wrong. This just speaks to, yes, they targeted what may have been a spurious gravity isoshell, and they almost certainly targeted a spurious 1D TEM inversion. But hey, they still had some geological information. They put it all together. I'm North American or Canadian. I like ice hockey, and it's playoffs now, and people often say, especially of goalies, you have to be good to be lucky. And then again, George Box, all models are wrong, but some are useful. So that's it for my talk. How did I do time-wise? Probably right on time.
Excellent. Joel, just a quick question from my side. Are you keen to stick around for the for basically the end of the session, or do you need to duck now?